Okay, so next section that we want to do, we already did with the section D. So now we have to know look for section uh, E. Okay, okay, see, hey, see, see. Okay, then we will continue with the rule here. Okay, the next section, section D, is special rule, special for formula with proof. Okay, you have a 24. 24 is a sine square. Okay, sine square kx, and 25 cos square kx. Okay, we have 26 ln x, 27 tangent, 28 cotangent, 29 secant, 30 cosecant. Okay, so, okay, this one is put as a special formula for it because from the past, during exam, they actually ask students to prove them before. Okay, to actually. So, 24, 25, 26, I'll leave it aside first. Okay, I will continue with the integration of the tangent. Okay, so 27. Okay, integrate of tangent x dx. How do we actually even get what is the answer? The proper way to study this 27, 29, 28, 29, 30 is to memorize answer and do differentiation. The correct way to actually remember this is to memorize the answer and do differentiation. Okay, so it's quite difficult for us to do integrate tangent x and to discover that it's actually ln secant x. It's very, very difficult. Okay, of course, once the students get used to it, they already know. But for first timer, it's actually quite difficult. Therefore, this one, the best way to actually study this is actually from the we memorize the answer, then you do differentiation. So we want to do differentiate of ln of secant x. Okay, ln of secant x. According to the ln formula, okay, if you have inside, you write at the bottom. Okay, the differentiate of the inside, you write on top. Differentiate of the inside, we will expect students to already know how to do the differentiation already. Then I have the secant x tangent x. Okay, then you can see that the secant cancel off. Then it become tangent, right? Can you see that? Can you see that?
Yes.
Okay, what exactly is the reason why I say that it's very difficult for us to understand from integration way? Because you see, if you look at the differentiation, we are canceling something off, right? How, when you do integration, it has to be reverse process. How do we even know what to actually add it back in? It's quite impossible for us to know what to put it back in. Okay, this is why that you actually study is by remembering the differentiation instead of the integration. Are you okay? Okay, then 28 you have cotangent x. Again, how do we even know the answer? As I said earlier, we remember by using differentiation. Okay, so I have ln of sine x. Okay, so whatever inside we write at the bottom, differentiate of the inside I write on top. I will cos x, differentiate of sine goes to cos. So cos over sine according to triple is cotangent. Done. Okay, 29. How do I know what is secant x? Okay, how do we actually know that the answer for the integrate of secant x? Again, we remember by memorizing the differentiation, the answer. The answer is ln of secant x plus tangent x. Okay, ln of secant x plus tangent x. So whatever inside at the bottom, we leave it as it is. Okay, then differentiate of secants, we have secant x tangent x. Differentiate of the tangent, I have a secant square x. Okay, so this is by section B, we will actually manage to remember this rule. So therefore, from here, the secant, you actually, when you take it out, okay, we can actually factor it out. So tangent x plus secant x. Then you have a secant x plus tangent x. So now you will see that a secant plus tangent cancel, secant plus tangent cancel, then we have a secant x. Okay, so you can see that if remembering it by using differentiation is actually a much easier approach. Okay, so the d integrate of cosecant x, what is the answer? Okay, again we remember them by using the differentiation. Okay, so I have a cosecant x plus cotangent x. Let's see what happened. Okay, I'll have the bottom of cosecant x plus cotangent x. I have a negative. Okay, this negative is from outside here. So then I need to differentiate of the inside. Okay, differentiate of the inside. Cosecant give us negative cosecant x cotangent x. Okay, then integrate differentiate of the cotangent give us negative cosecant square. So from here, we can actually see that the negative sign, we can actually put it inside. So you have a cosecant x, cotangent x, plus cosecant square x over cosecant x plus cotangent x. Okay, so cosecant, we actually can take out cosecant. Then we have a cotangent x plus cosecant x. Okay, we have a cosecant x plus cotangent x. So now you will see that this can be cancelled off because they are the same thing. Therefore, you're left with a cosecant x. Okay, so this will be the answer for the proving. Okay, the again 24, 25, 26, not yet. Okay, not yet. So then after that, now this is E. Okay, this is just E special formula. Then F, integration technique. Integration technique. Okay, so over here we will assume that students already okay with A, B, C, D, E. Okay, we will assume that students already okay with A, B, C, D, E. No problem with the A, B, C, D, E already. Then this integration technique will be the main part of P3 questions. Okay, so it's already come to technique, it's no longer formula. Okay, it's come to technique, no longer formula. Therefore, when you look at the question, you have to consider things like, okay, do I need to use this technique or not, or do I need to use other technique in order to actually answer the questions? Okay, the first technique is called by substitution. This is, I put it as a rule number 31. Okay, by substitution. Okay, that means we change something y, okay, in terms of x into something else. Okay, into something else. Something else. Okay, the purpose is to make something complicated into something easier. Something complex into something easy. Okay, so if you do a substitution question but you make it more complex, then actually defeat the purpose lah, because the purpose is to make it into something easy. Another thing that you need get aware is for P3. Okay, the question always tell you what to substitute. Okay, the question will tell you what to substitute. Therefore, you shouldn't be worried much about how to actually do the questions. Okay, so let me just show you some example of the exam type questions. Okay. Okay, let me show you some questions. Sample. Okay, mass P3 integration. Okay, let me check. Let me see if got anything here. Good. Mm. Okay. So let's say this is the question. So you will see that the question will, as I said, they will tell you what to substitute, and it shouldn't be a problem. Okay. The second, the second part is it's a continuous question. So together, if you know how to solve the question, it's already 8 marks done. So how do I actually do the thing then? Okay. So from x equals to 2 tangent theta, so I dx d theta equals to 2 secant square theta. Then I will write dx equals to 2 secant square theta d theta. Okay, over here I have an x value given x equals to 2, then the theta we can then we can get 2 equals to 2 tangent theta, theta equals to pi over 4, given x equals to 0. So 0 equals to 2 tangent theta, so theta equals to 0. So once everything are ready, we actually can start substituting. So from 0 to 8 over 4 plus x square square. So 2, so this one changed to pi over 4. 0, this one changed to 0. 8. So x here is 2 tangent theta, so I put it in. 4 plus 2 tangent theta square. Okay, dx here, dx is 2 secant square theta d theta. Okay, I'm better write them properly. All right, underneath. Okay. So this dx here, I change it into 2 secant square theta d theta from here. So let's actually see from here. Okay, I replace the time bit. So let's see what do I get then. Okay, so I have an equal pi over 4, 0. Okay, so I have an 8. So this one I need to expand. 4 plus 4 tangent square, then with a square. Okay, so this one becomes 16. 8 and 2 together become 16. And the secant square, theta, d theta. This one will be depends on your basic of chapter 1, 2, 3 already. So if your chapter 1, 2, 3 is strong, then this one will be able to tackle them easily. So you have 16 of the secant square theta. So 4 here can actually take out 16. So with 1 plus tangent square theta square. And you are half of pi over 4, 0. 16, 16, of course, it will be cancelled. Okay, according to the identity, 1 plus tangent square is a secant square, where with a square here. This is trigo. This part is trigo. D theta. So you will left with pi over 4, 0 with 1 over secant square. 1 over secant square is pi over 4, 0 cos square. Okay, 4 marks. For first 4 marks, actually need you to do this. You can, as I say, you can actually see the level of P3. The level of P3 is no longer easy. Okay, you are expected to actually know how to do this kind of questions. Then from here, is a continuous questions. Okay, then ask us to continue finding the answer. So I have a integrate of pi over 4 0 cos square theta d theta. Okay, so this is the special formula. This is the special formula here. You actually can see from here cos square 1 over 2 bracket x plus sine x plus x. So we continue. So over 1 over 2 of theta plus sine theta cos theta with pi over 4 and 0. And by the way, don't expect this is you have this in the formula booklet. Huh? You don't have this in the formula booklet. So you have a pi over 4 plus sine of pi over 4 cos of pi over 4 minus 1 over 2 0 plus sine 0 cos 0. Okay, so 1 over 2 pi over 4. This one 1 over square root 2. This one 1 over square root 2 minus 1 over 2, and this is 0. So in the end, you have this is 1 over 2, 1 over 8 here with pi plus 2. So 1 and 2, 2 over 8. Yes. So this one is the answer. 1 over 8 pi plus 2. So of course, for students who actually practice enough formulas, this will become very very easy. Okay, and furthermore, this is among the 3 techniques up here for your integration technique. This is the easiest technique. Okay, this is the easiest technique. This is the one that students most comfortable because of they always tell students what to substitute. Therefore, it becomes easier in that sense. Therefore, for you, you will have to know how to actually tackle the question. Okay, when you are looking at the substitution. Okay, so best is to let you try out the question. Okay, okay. So you can see that there are different type of substitution. Okay, that you actually can do. I hope that you all can start working on your work. The what did I say? The World Cup is already over. Okay, Argentina already won. So now it's time for you to continue with your work. So this one is exercise 6F. Okay. Hmm. Exercise 6F. Okay, today you do one technique, then the rest of the topic, okay, I will put on YouTube for this. Okay, I think that's all for today.